Coral reefs are incredibly important to our planet, but despite their relevance, these vital ecosystems are facing a serious threat due to climate change. And the consequences extend beyond just the environment itself. So to shed some light on this critical issue, we have put together this panel titled Coral Emergency: Perspectives on Reef Ecosystems Under Climate Change. Here, our panel of experts from different fields will explore what it means to each of them to face the risk of losing coral reef systems. Hopefully, by the end of this seminar, we all have increased our understanding of how different areas intersect with coral conservation and how this can help us in addressing this urgent problem. But before we move into introducing our panelists and more details of this event, we would like to acknowledge the land we are gathering today. So the Marine Studies Institute at the University of Sydney gratefully acknowledges and pays our sincere respect to the Gadigal people of the Eora Nation. They are the traditional custodians of the lands upon which our university stands, and it's upon these lands that we gather today. Furthermore, we extend our deepest respect and recognition to the Aboriginal and Torres Strait Islander communities, the first scientists diligently preserving and nurturing land and sea country for thousands of years. Finally, today, we believe the proposed amendment to the Australian Constitution is a fundamental step towards truth-telling, reconciliation, decolonization, First Nations self-determination, and the recognition of sovereignty. The Aboriginal and Torres Strait Islander people's voice will be forever indispensable for the ongoing endeavor to safeguard our invaluable lands, oceans, and coral reefs. So, have done the appropriate acknowledgement. We need to go for some housekeeping before we dive into the panel. First, in case of emergency, please remain calm, and we will follow the instructions provided by the building warden. Emergency exits are located at level 2, the street level, with access through the main stairs. There is also a direct exit located here in level 0 on the far right corner of the building. Toilets are located to the right as you leave this room. Walk all the way to the end of the corridor, passing by the main set of stairs, and you should see a toilet sign. Water fountains are also available in the same location. Also, please kindly set your mobile phones to silent mode to avoid disruptions of the session. In terms of our schedule, our panel will end around 5:30 p.m. We started a bit later. Following the panel, we invite you to enjoy some light refreshments in the hallway just outside the room. In addition to that, we have designed our discussion format as it follows. So first, we will pose a general question to all panelists. Then each panelist will receive a specific question according to their expertise. And then after this, we will open the floor to questions from the audience, both those joining us in person and online. For our online audience, please feel free to submit your questions through the Zoom chat. Professor Eleanor Bruce will be moderating and relaying your questions to the panel. And then if you are here with us, please just raise your hand and we are going to provide you a microphone. The session is also being recorded and these will be available in YouTube, right? Yeah. Okay. So now introductions, because I've been talking and I didn't even say my name. So my name is Ana Paula. I'm an oceanographer focused in researching coastal variability, wave dynamics, and the effect of large-scale climate drivers. Currently, I'm a postdoc research associate at the University of Sydney in this ARC discovery project that aims to investigate the ecomorphodynamics process on the Great Barrier Reef and provide projections until 2100. The other co-chair of this event is Dr. Shona Fo, who is an ARC and Westpac Research Fellow at the University of Sydney. As a marine scientist with an interest in the biology, ecology, and evolution of marine ecosystems in a changing climate, Shona's research investigates factors that increase the resilience of marine ecosystems to climate change stressors. During her career, she has used many fascinating technologies such as remote sensing techniques and systems such as CO2 vents to understand the health and function of marine ecosystems. Today, Shona will be here as one of our panel members, providing insights from a marine science perspective. Please join me in giving a warm welcome to Dr. Shona Fo. So next to Shona, we have Mr. Eric Poole, who is currently the Innovation and Technical Manager of the Sydney Fish Market. Eric took up a role in quality assurance with Sydney Fish Market in 2005. Prior to this, he worked as a qualified skipper operating fishing vessels in Papua New Guinea and the Northern Territory, and completed a fisheries science degree at the Australian Maritime College in Tasmania. Eric is now responsible for overseeing the Sydney Fish Market's quality assurance, food safety, and engagement with stakeholders in the seafood industry, particularly related to quality standards, grading, and technical projects. Please join me in giving a warm welcome to Eric. Supposed to be passing this on. Here's Eric. So next we have Dr. Pat Hutchings, who is a senior fellow at the Australian Museum. Dr. Hutchings' research focuses on the systematics, phylogeny, and ecology of polychaetas and other marine invasive species, and the role that they play in benthic ecosystems. Pat's research also involves experimental studies on the bioerosion of coral substrates and how rates are changing with climate change. Please join Dr. Pat. And last but not least, we have Professor Tim Stephens, who is currently a professor of international law at the University of Sydney. Professor Stephens teaches and researches in public international law, with his published work focusing on the international law of the sea, international environmental law, and international dispute settlement. Tim has authored and/or edited 11 books. His major publications include The International Law of the Sea, which has multiple editions, the latest one, 2023, co-author with Donald Rothwell, and International Courts and Environmental Protection, last edition, 2009. Please welcome Professor Tim Stephens. Okay, now let's get started. This question is for all panelists, and I guess we are going to start with Dr. Fo, and then we go as you are sitting in your order. So tell us more about your expertise and how do coral reefs relate with your field? Basically, what do they mean to you?
So, hi everyone, I'm Shona. So I'm a research fellow at Sydney Uni. So as Anna mentioned in her introduction, before coming to Sydney Uni, I worked overseas in places like Italy, in places, these special CO2 vents, which are really cool sites where CO2 bubbles up from the seafloor, lowering the pH to levels that we can expect to see with future climate change. And so it's a really cool natural system to study how animals might adapt to these conditions. Then right before coming to Sydney, I was working mainly in Hawaii, in Hawaiian reefs, using remote sensing techniques, so satellite technology and special sensors on planes to map reefs and assess patterns at larger scales. But now at Sydney Uni, so all my work, mainly revolves around coral reefs, and I have, alongside a great group of students, there's I look at coral reefs and the impacts of climate change on them. And so there's a few major themes to my research. One of the main ones is studying corals that live in marginal or extreme systems. So these are systems where we don't really expect corals to live because the conditions are really far from optimal. And so they're a really cool place to understand how corals might adapt to future climate change because they're living where we don't expect them to live. And so a system that I'm interested in is this intersection between mangroves and corals. So we see corals in a lot of tropical regions, we see corals living near mangroves, and mangroves tend to make the water low in oxygen, change the temperature, change the pH, and there's corals still living there. But the mangroves can also provide extra nutrients that the corals could utilize. And so there's this balance of positive and negative factors. And it's just really interesting to understand what kind of, or how are the corals using that and, surviving there. So another theme of my research is studying coral-associated organisms and animals that actually destroy the reef, like crown of thorns sea star. So I'm sure a lot of people have heard about it because apparently this, the sea star's eating the whole reef. So a lot of the research that I do is trying to figure out some of the best ways that we can mitigate this animal. And so, we look at it at its larval stage. So this giant sea star, starts through a tiny little larvae, and these larvae can actually even clone themselves. And so that's, one way that they're really successful in, outbreaking and eating all of the reefs. And so we're also studying the adult animal and looking at things like what kind of coral they prefer to eat and how much do they eat, to just understand the best ways that we can mitigate this animal. But yeah, so corals, mean a lot to me.
Yeah, it's interesting because like we are both marine scientists, but everything you talked, it's completely different from what corals mean to me. Because as an oceanographer, corals for me mean coastal protection, meaning like all the relation with the coastal zone, the possibility of creating an island, wave attenuation and everything else. So yeah, even inside of the marine science, there is so much to think about. Eric?
Yeah, so Eric Poole, I guess what corals mean to me is habitat and home for multiple marine organisms. So I grew up in Papua New Guinea on a little tropical island, which I was lucky enough. There we go. So yes, they mean a lot to me because I grew up in a subsistence community where my mum's sort of family and relatives and extended family all depended on corals for their livelihood. Now that obviously going from there to a commercial fishing space, the impression is that most fishers are obviously having an impact on the ecosystem, destroying sort of species and overfishing, like you've heard of all the sort of news grabs. What I'd say is that through my time sort of researching and then getting a job where I work now at the fish market, is that it's not all bad here in Australia. And I think we get tarnished with a brush that is broadly stroked across the international space. In Australia and New Zealand, we're fairly lucky in that we have very good fisheries management. And I guess the comparison I draw from what we do now in Australia compared to where I grew up is that with quota and fishing rights, the fishers are essentially fishing to maximum economic yield rather than maximum sustainable yield. So it's actually more conservative because if they're not going to earn money for what they're catching, they're not going to go fishing. And so in my eyes, that's a really good sort of management tool. What I'd say also is that management relies on data. So as much data as you can gather, whatever that source is, you need it to be able to manage the resource. And so at least with commercial fishing, there is that capture of data. A lot of contention around recreational fishing and other sort of sources of impact on the resource. And so I'd say that, for us to manage the resource well, we need to get as much data as possible. And so it's, you know, in the interests of the fishery and the resource to be able to capture that. And, you know, we often forget that what's in the sea is influenced by what's on the land. We often quote in my industry that when there's a drought on the land, there's a drought in the sea. And that's because all the nutrients that wash down our catchments and into the ocean, they all have an impact. So on the barrier reef, there's, you know, issues with nitrogen and fertilizers and other things that get washed out onto the reef that we don't really quantify as well as we probably should. And some of those have been linked to crown of thorns outbreaks. And it matters for us in the commercial space as well, because some of those issues then create other problems like ciguatera. So when you get, you know, damage to coral reefs and they stress, they then, you know, encourage the growth of certain dinoflagellates, which then lead to ciguatera poisoning cases, which affects, you know, the whole community. So for me, that's what I'm passionate about, is like managing the resource so it's there for future generations like my son.
Well, good afternoon, everyone. It's a great pleasure to be here. So I'm Tim Stevens. Dr. Fu, I think, said before that everyone here is a scientist. I've got a confession to make. I'm not a scientist. I did do a geography degree in the UK, and I was forced to do a training session, a safety session in Bunsen burner safety and chemical safety. But I did a thesis on fisheries governance and not on the science relating to fishing. So I'm sorry, I'm not a scientist, but I am a lawyer, and I've been deeply interested in the management of marine spaces really my whole career. I've been doing work on and off on coral questions since about 2002. In that year, along with a colleague, we wrote a big report for Greenpeace. Actually, it was commissioned by Greenpeace and by also the Climate Action Network Australia, looking at Australia's obligations to protect the Great Barrier Reef from the effects of climate change. This is in 2002, a long time ago. And the argument we made was that the World Heritage Convention, which we may talk about later in this session today, imposed obligations on Australia to go above and beyond the then minimal emissions reduction obligations set in the Kyoto Protocol. And I'm sure we'll get into this today, but this central problem with protecting coral reefs is that an exclusive place-based management system just won't work. It only gets us to a certain point, and we have to look at global factors, global influences, and deal with, you know, global challenges, climate change and ocean acidification. And a lot of my work has been focused on how we overcome that challenge. So that's me.
Hi, I'm Pat Hutchings. I'm a senior fellow at the Australian Museum. The Australian Museum, hopefully most of you have been there, is one of the oldest natural history museums in the world. We were founded in 1827, and it's actually we have enormous collections. We have something like 22 million items. And a lot of that is data-based and available either on ALA, Atlas of Living Australia, or the Australian Fauna Directory, AFD. The AM has been, as I call it, involved in the GBR for a very long time. There was even the earliest expedition I can find was back in 1925 when they went to Northwest Island in the Capricorn Bunker Group. And, you know, they took fish people, mollusks, echinoderm people, and made large collections. And since then, the Australian Museum has had numerous surveys done, expeditions, where they camped on islands in on the Great Barrier Reef and also Lord Howe. Now, in the late 1960s, we had a new director called Frank Talbot, who was from South Africa, who was a fish guy. And he initially came as the fish curator, and then in 1968, he became the director. And he'd done his PhD in Mombasa. And he was really interested in the biodiversity of, you know, how many fish species were. And he managed to set up a small island research station called One Tree Island, which we ran till about 1973. and now Sydney University take that over. Now, I arrived back in Australia in 1970 from the UK, and my knowledge of Great Barrier Reef was very limited. We had some lectures, but this was before the days of the David Attenborough films. You know, we had no movies as to how wonderful the GBR was. So Frank Talbot came into my office and said, "Can you dive?" And I said, "Yes." He said, "Right, I need someone to help me build artificial reefs at One Tree." So we flew up to Gladstone, and I caught the helicopter over to Heron Island. My God, this is so beautiful. This is where I want to work. Anyhow, we then caught the boat out to One Tree, and I worked out during those 2 weeks of laying these silly Besser blocks, a lot of which blew over in the next storm, but never mind, that I really wanted to work on the reef. And I sat there and worked out a grant to get it. So anyhow, in 1973, Frank Talbot had documented the biodiversity of fish at One Tree, and he wanted to then compare it with what was in the northern part of the reef, because there was this idea that the reef was a sort of constant environment, but in fact there's something like a 10-degree difference in water temperature from Lizard down to One Tree. And so we went up with a benefactor called Henry Loomis, and we went up to Lizard. First of all, we went to Cairns and we chartered a boat and we looked at various islands. Anyhow, we arrived at Lizard, and we were very keen on Lizard because you could fly there in a day from Sydney, and there was an airstrip being developed, and they'd also had a lease for the Lizard Island Resort. So it was going to be technically very easy to work. And Lizard, it's back now, it's the 50th anniversary this year of Lizard Island Research Station. And it's a facility of the Australian Museum. So it really has, the museum has extensive collections, not only of fish, but of invertebrates. Now, we've held over at Lizard Island, where I have probably spent 2 or 3 years of my life over the past 50 odd years. We've had workshops there on amphipods, mollusks, fish. And in 2013, we had a polychaete workshop. In 2 weeks, we managed to collect and describe 91 new species. And this really highlights that we got all this information about fish and corals, perhaps, but we really don't know much about a lot of the invertebrates, and polychaetes would be amongst them. Now, the other museums in Australia also have good collections from coral reefs. The West Australian Museum has done extensive surveys on the coral reefs in Northwest Australia, starting from the Abrolhos right up into the Kimberleys. The Museum of Tropical Queensland in Townsville has obviously extensive coral collections, and the museum in Queensland, in Brisbane, has extensive sponge collections, as well as all the stuff that was collected in the cross-shelf transects, because coral reefs are more than just coral reefs. They are also these sort of interreefal habitats, that sediment. And that's reflected in the new zoning plan, where we actually were involved in making sure that we had representative areas in all those habitats, in all those bioregions. So I think this is really, so basically the museums in Australia have really good collections which need to be looked at and worked on. We've got perhaps a good example of museum data is that there's a whole suite of species that can only live in live coral. So what happens when we get these successive bleaching events and death of coral? Those invertebrates that can only live in live coral, basically you end up with local extinctions. And if the bleaching continues over extensive areas, we're going to end up with not just local extinctions, but real extinctions. Now, my own research, as well as documenting the polychaetes, that's what I work on, sea worms, I've also been involved in biodiversity studies. Now, on a healthy reef, the reef is a balance between reef growth and reef destruction. But when we keep getting bleaching, we get more dead coral. So that balance shifts. And so we're going to end up from a coral reef dominated reef to an algal dominated reef. But bioerosion is a normal process. You can look at fossil coral reefs, and I've been working with Jodie Webster and Maddie Patterson here at Sydney Uni. And there's good, if you look at geological cause of coral reefs, you can see that you had bioeroders in those days. So the reef is, as I say, is changing. And I've certainly seen changes in the 50 years that I've been diving on the GBR. And even then, and I've worked in the Pacific and seen the devastation in some of those places. So my final plea would be, while we're going to talk a lot about corals and fish, there really is a very large percentage of the biodiversity of coral reefs here in Australia that is still not described. And we really need to know some of that, because how do we know whether the management plans that we've developed and the monitoring, how do we know whether we're actually protecting those benthic communities that are the bottom of the food chain? So I think that's why museum and their collections really do play a critical role.
Thank you. That was great. Yeah, I'm already super interested to hear everything else from all the four of you. So now going to some specific questions. I think some stuff you guys already touched, but we'll try to move around that. So Shona, I will start with you. Could you, as our marine scientist expert here, tell us about how has climate change impacted the reefs? Like, what have you been seeing in One Tree Island and all these reefs that you've been? No, you need.
Okay. Okay. So maybe this will be basic for a lot of you, but maybe you also don't know how climate change is impacting reefs. But so there's, the climate change is impacting them in many ways, but there's maybe three main ways it is, and the one that is most common and the most prevalent stressor is ocean warming and heat waves. So the ocean is a huge sink for this excess heat. And so the ocean is increasing in temperature. And as we know, that's really bad for corals because they're used to living in really stable environments. So anything, 1 degree over what they're used to living in can cause them to start bleaching. And bleaching is when they, get rid of that algal symbiont that lives within them. And that symbiont is what photosynthesizes and why people think corals are plants, but provides, most of the energy to that coral. So that relationship's really important, and it breaks down and they bleach when the temperature's too hot. But it doesn't always mean coral death. So if, the temperature goes back down, the coral can regain this algae and start to function normally again. So another way that climate change is impacting coral reefs is also through changes in pH. So the ocean is also acting as a sink for this excess carbon dioxide, and through a range of processes, it means a decrease in ocean pH. And so that also impacts the coral in many ways. And one of the main ways is that it reduces the amount of carbonate ions that are in the water, which is the main building blocks that corals use to build that skeleton. And that skeleton is the basis of most of the coral reef's function. It provides all that habitat structure that all the animals live in. And it's also that functional structure that, dissipates wave energy and protects shorelines. And so with changes in pH and reductions in pH, we're seeing corals growing, weaker skeletons with more holes. And so their function is going to, be worse and affected by ocean acidification. And so the last stress I'll talk about, these are not all the stresses, but another one is deoxygenation. And so with changes in temperature, with warmer waters, the saturation rate of oxygen is lower. And also there's less mixing of layers in the ocean. So that means there's like regions in the ocean like these oxygen dead zones. So again, decreases in oxygen levels also affect corals, so that if they're trying to protect themselves from that stress, they tend to redirect the energy from growth to protecting their cells. So again, that's with deoxygenation, we're seeing impacts on coral growth. But yeah, so unfortunately, the prognosis for corals isn't very good. They, expect by the end of the century, up to 90% of reefs are impacted by climate change. But hopefully, some of the research that I'm doing and lots of great research they're doing looking at these corals that are living in these marginal or extreme systems, give us some hope that corals can actually adapt or acclimatize faster than we think they can.
Okay, so main stressors in your In a summary, deoxygenation, pH, and bleaching. With
heat
temperature. Yeah,
warming.
heat warming. Yeah. Cool. So, Eric, I think you also started touching a bit on this, but in light of your upbringing in this remote community in Papua New Guinea, with this strong tradition in subsistence fishing, how do you think that the knowledge and practices that you had in your community could be applied in this seafood industry that you work so close today, and how consumer choices also could be used to minimize the impact on coral reefs?
Yeah, so I'd probably I'd say that in a normal subsistence culture, people manage the resource by a multitude of ways, whether it's taboos or, seasonal closures of areas. So people would just stop fishing in a certain reef, and it was taboo to go to that reef. You'd have to fish somewhere else until they noticed a bounce back, or if it was sort of some fishing methods that were not so sustainable. So there's a type of tree root that they use. I only know the traditional name, but it's a saponin. So when you beat it up and put it in the water, it starves the water of oxygen. But unfortunately, that's also bad for reefs. And so people would manage, there might be certain closures on reefs where they didn't use those methods for 1 or 2 years. And they would obviously, through observation, know when to reopen those sort of reefs for fishing and cultivation. So some people, would make clam beds. So when you put a bunch of adult clams together and they spawn, you'll get settlement downstream from those. So people, they're actually dependent on it for their food. And I guess going forward, some of the difficulties are that a lot of those traditional subsistence areas are getting more and more populated. And so it's getting harder and harder to manage. I think the thing we can learn from those, which in some cases we're already applying, is through area restrictions. So there's marine protected areas now. People are still assessing the efficacy of those, but I think they're largely a good thing. And, that's one thing. Quota is another. So you're only allowed to catch a certain amount of a particular species. So in New South Wales, for example, we have eastern rock lobster, where every single lobster has to have a tag so that you know exactly how many, animals are coming out of that system. But the biggest thing for me is just getting all that data. So, knowing what all the effort that is going, into fishing, and then managing that to, control, I guess, the outputs from the fishery. So we've gone from one where they, it was input controls. So they controlled the size of the vessel you could use, the size of the engine, etc., to one of output controls. So, we're now managing through quota and through other things. Australia is lucky and unlucky in some respects because we've got, hundreds of species, but generally low volumes of those. And a lot of those are based on coral reefs. So as you know, there's, over 600 species of fish on the Barrier Reef alone. I was fortunate enough to grow up in an area that's in the Coral Triangle. So they had, over 1,000 species. And about 50 kilometers up the road from the island I grew up on is an actual study site for, because it's volcanic as well. So you get a lot of this carbon leaching, bubbling up through the water. And so there's a lot of studies done. And I guess for me, the scary thing is going forward as we get more ocean acidification is all the juvenile prawns, mussels, fish, you name it, they all have shells. And they're going to be impacted without us being able to see generally, like for the average person in the public. And anytime there's, I guess, a stock assessment that points to a decline, they point the finger at the fishing industry, because that's obviously the most obvious and visible impactor. But like I was saying earlier, everything that flows down a river, everybody's got a garden. They go and buy stuff from Bunnings and whack it on there. The next flood comes along, or even a rainfall event, and all of that washes down and into our marine ecosystems. And so, we're the most visible target, but I think, people actually understood what the drivers were. They'll see that it's just the growth of human populations, and we're all moving to cities. I even see back home where I grew up, as the population grows, people are becoming less and less respectful of those traditional taboos and management measures. So it's a problem for everybody. And the clock's ticking, I guess. It is scary, but there's still time to do stuff. It's just whether we can, get the motivation and drive to do it.
Thank you. So now we have the microphone with Tim. So I'll ask you, maybe, hopefully, in a positive note, but let's see. Could you provide to us some successful legal agreement that have positive on a global scale?
I guess there's a number, but perhaps it's worthwhile just dwelling on, at least Eric made so many great points just then from a fisheries management perspective, but I think it's really important to dwell on the point he made around where we go in terms of managing any kind of marine ecosystem first in seeking to control human impacts on it. And we will go to the obvious pressures, whether that's fishing effort, whether it's pollution, runoff or whatever. And it had never really occurred to me, and I'm grateful to Eric for pointing this out, but there's going to be people that are going to get caught in the middle as these ecosystems encounter this state shift, and they're going to get the blame rather than the global community in terms of emissions and so on. But coming back to your question, Anna, are there success stories? Yeah, but up to a point. And there's kind of temporal limits on those as well. So we can say there's been success up to now, maybe, but looking over the horizon, are they going to continue to be successful? So let's just think of one in particular. I think the World Heritage Convention has been an example of a success story to a point in protecting several coral reefs, including the Great Barrier Reef. The World Heritage Convention is an old convention. Don't know how familiar people are with it, but it emerged in an early period of international environmental law, where we were most focused on the aesthetics of the environment, not necessarily on ecosystem function. So there's lots in the convention about, protecting the beauty of nature and passing it down to future generations. But nonetheless, it set off a really important process that ultimately led to things like, the Great Barrier Reef Marine Park Authority and the terrific management system that we have for the Great Barrier Reef, which remains a really good global example. We get very down on the Australian government's management of the Great Barrier Reef in Australia for good reason. I know this is going out on YouTube, probably won't win any friends in government in saying this, but globally, it's not too bad compared to a lot of coral reefs. But the fundamental difficulty we've got, and this is a point I made in my introductory remarks, managing marine spaces through a focus on marine spatial planning within defined boundaries will not address the global pressures that we've got. And so how do we square that circle? In my view, there's a few ways we can think about doing this. I think actually the most important thing to do would be for reef managers to start to come up with, based on really good science, some metrics or benchmarks as to the kind of safe operating space for these spaces. Now, there's global work happening on this. Don't know whether people are familiar with the planetary boundaries framework. So that's kind of setting a safe operating space for humanity kind of globally. But I reckon coral reef scientists in particular, and I know there's, you know, good work being done on things like aragonite saturation and the extent to which, you know, we're going to be falling below certain levels of the availability of carbonate ions and so on. But I think much more precision needs to be brought to bear. I think we need, like, when it comes to, say, a health card for the Great Barrier Reef, we need it really clear that we know that if temperatures rise by so many degrees or points of a degree, and if pH drops further in terms of units, you know, pH, then that's what it means for the Great Barrier Reef. Now, I know it's difficult from a science perspective, and you know, the Great Barrier Reef is a great example because it's a diverse ecosystem. As Pat said, was you, Pat, 10 degrees? Was it Shauna, 10 degrees? Yeah, between the top and the bottom in temperature. Today I've spent a lot of the day working on some work on the Arctic and ocean acidification in the Arctic. That's an incredibly diverse marine environment. In some parts of the Arctic, ocean acidification is a real problem. In other parts, it's not yet a problem. It's really fascinating. So it's tough, but I actually reckon kind of needs to be where we're heading towards. We need to have some metrics that we can measure performance against, and then we can get some good advocacy. So organizations like the Great Barrier Reef Marine Park Authority can go out and say, not just climate change is the greatest threat affecting the reef, which is true, but they can actually put some numbers behind that, saying we need to hold temperatures to 1.5 degrees globally or less, to be honest. Yeah, so convoluted answer, Anna, but I hope that was helpful.
Okay.
That was helpful. I was already thinking of other questions for you. But for you, Pat, so maybe there is this narrow view that, you know, museums are holding the story of the past, what has been happening and everything. But my question to you is, how do you think that we can use all this knowledge from museums? How can museums help us actually to look to the future, to projections, to change the future of coral reefs?
First of all, the museum collections, which are increasingly being databased and available, can actually document the biodiversity. So, you know, make sure we know what we're actually trying to protect. But also we can look at some of the dominant groups and see how they've changed in distribution over time. This is an example, not, for instance, in Sydney Harbour, the first marine invertebrate was actually documented from 1851. So we can document changes in distributions over time. It's not as perhaps the collections weren't necessarily done in a totally standardized format, but they can give us some ideas. It's the best we've got. And the other thing I just would like to follow on from what Tim's just talked about is that we can't manage the GBR in isolation. I was involved in the rezoning of the reef back in the early 2000s, is that we need to look at jurisdictions, the land jurisdictions. You know, we've cleared all those major rivers, the catchments of all most of the major rivers flowing onto the GBR, and yet that's managed by state government, whereas Gurumpa is managed by the feds. So we need, and then the islands on the GBR are managed by state authorities. So there has to be a lot of this jurisdictional problem that have to be solved. But no, museums, you know, need to be involved, and you know, as I said earlier on in my beginning when I started talking, is that we need to, are these management plans that we're putting in, which is wonderful, you know, we've got 33% of the GBR now in protected green zones, but is that sufficient? Do they need to be moved? as the fauna starts to move further south, as water temperatures rise? We don't know. So that, I think if you think about, actually the museum was the Museum of Tropical Queensland was very involved in that amazing work that was done on the mass spawning of corals in the late 1980s. Up until that stage, we had no idea how connected all the reefs were. So that's, really shows the importance of museums. But also, I think all of us scientists, whether we're based in government departments, museums or universities, we all need to work together. But there needs to be far more collaboration rather than having these sort of isolated little bits. So, I mean, Lizard Island Research Station, we encourage students, academics, whatever, to come from around the world. And so having that stable base at Lizard has been very important to look at long-term changes.
Thank you. That's great answers so far. I'm wondering if the audience has any questions. Do we have any questions online to start? No. Anyone in person? Yes, there is one hand here. We'll get a microphone to you.
Hi, I had a question for Shauna, if that's okay. Yeah. Yeah, so you talked about that there are algae that live in symbiosis with the corals. So is there a known change in the corals when the temperature rises that drives the algae away? And if we know that, can we maybe formulate a way to prevent the corals from bleaching?
Yeah, so that's a great question. And so there's a lot, I don't research that area specifically, and there is a lot going on with that. They're trying to understand, is it the coral that decides to eject the algae, or is it the algae itself that decides it doesn't want to be there and leave? So that's, yeah, there's a lot of research. It's not such a clear-cut question, but basically whatever happens when bleaching can happen, not just with temperature. If there's no light, corals can also bleach. If there's too much pollution, if it's too turbid. So basically something just happens that makes that relationship not like beneficial for either of them. And so they just break apart. So, and that's, yeah, it's not completely known, but I'm sure if they did know, that could be an easy way to stop bleaching. But yeah, it's not that simple, unfortunately.
Thanks.
I don't want to be a troublemaker. But maybe there's too many biologists. I don't know. Well, surely one of the elephant in the room is that these environments also have one particular species, Homo sapiens, living on surfaces that are deemed, I think, by large segments of society in Pacific and Indian Ocean as being very vulnerable. So the real biological question there is, I mean, there's the primary drivers of whether we have failed states or not is actually sea level change and sediment production. So for the biologists, one of the big questions is impacts on sediment production from the and most of it's, of course, carbonate sediment from the various sources. So there's the aesthetic and, fisheries related question. But this seems to be a huge issue. And I haven't worked on coral reefs for over 10 years now, but it was a question that carbonate productions was something that was really a grey zone. And part of that grey zone, which pertains to the things you've already been talking about, is if we're looking at change, mean trend type change driven by the climate drift, is the signal to noise ratio in any of the metrics that you care to look at. So that sounds sort of like a comment, but it'd be interesting where the panel can address particularly this question of carbonate production.
Does anyone want to start?
Yeah, look, growing up again in Papua New Guinea, and this goes to the very diversity of corals. Like PNG doesn't have barrier reefs, so in the area I grew up, it's fringing reefs. And we've got some major rivers that flow into the ocean, so a lot of sediment, also fresh water, obviously, and the corals have never had an issue rebounding from that. So I think I saw on a David Attenborough documentary that some of the nutrients that wash out of the rivers in PNG actually go through undersea currents all the way to South America and the Galapagos. So these areas are all interconnected by these oceanic currents, and I guess the disruption of those currents and, you know, the subsequent issues we're seeing with climate change are just sort of one step too far for a lot of corals. So, you know, they've rebounded from multiple things. I've seen them, you know, go through cyclones, had major floods, and they always come back. But this is sort of a new challenge, this sort of sea level, I mean, the, you know, temperature changes, global warming, whatever you want to call it. It's human induced, and it's, you know, this is the sort of the next level challenge, I guess, for corals.
There's an interesting development today, or maybe yesterday, US time. The US president has announced that US will support Pacific island nations in maintaining their sovereignty, irrespective of whether or not they lose territory, and will also support their continued membership of the UN. So, yeah, law can't resolve the issue of necessarily the rising sea levels or the erosion of coral reefs, with carbonate being, you know, lost. But yeah, there's an effort being made already now, really important state practice to kind of preserve the status quo. Talk about carbonate or sediments.
Yeah, I think, yeah, I will compliment on that, and then I'll give to the other people. So yeah, we here now in the group, we are working in this thing that you were talking yesterday, actually, ecomorphodynamic study or a biomorphodynamic study, which is basically, so this is more like what scientists can do, and not really that we can change much, but we can try to understand what's happening. So when we are talking about a ecomorphodynamic study, we are seeing how the morphology, in this case, a reef and an island, changes due to some hydrodynamic and other stressors, and then how these will impact the sediment and also, again, back the waves, and then how this will impact the reef, and then it keeps in this feedback loop over time. And then in that, we have the carbonate budget production and the state of the reef. And we are trying to create this model that I'm being very hopeful that we will be able to create it. But we were looking into this research that did the whole thing that we are doing, but qualitatively. And they found out that we need 80 variables and 250 relationships to be represented, in this case, by equations, to be able to get all the relationships that we need to create an ecomorphodynamic study, where we are going to introduce all the potential stressors, how the reef will answer, and then how, after the reef answers, how that will impact if we are going to have more or less sediment being produced. And then if we have less sediment being produced, how that will feed back into the whole process. So it is a quite complex system that I know Peter knows quite well how complex it is. So that's why he's putting this question. So yeah, it is a very challenge to think about how we are going to predict this. We don't even understand. Not even today, we were talking, not even in a reef scale, I don't think we have a full, complete study that can calculate the whole carbonate production, budget, loss, and everything. And these will impact our islands all around the reef. So imagine in a reef, in a Great Barrier scale, and then imagine in a whole global scale. And we are talking about Australia and Great Barrier Reef that has a lot of data considered some other locations in the world. So yeah, this is also a comment. I don't really have a proper answer for you.
It's working. Okay. It's been a long time since I've been at the University of Sydney talking about corals, but back in 1998, 97 or 98, my boss, Ove Goldberg, put the cat amongst the pigeons by claiming, because he was working on the bleaching of corals, by claiming that reefs were going to be gone in 100 years. And University of Sydney had a communal heart attack and worried about the PR and everything else, and told Ove that he was a lunatic and all of these good things. And then he came out and apologized just a few years ago and said, I'm really sorry, but it's actually not 100 years, it's 50 years. So your planetary boundaries concept, I mean, I noticed the Copenhagen people came out with that planetary, we've gone past several planetary boundaries already that they've monitored. We don't know what we don't know, but even the best mind, what's that, 25 years ago, was predicting 100 and they were 100% out. You know, so I don't know whether we really need to know everything. Yeah, I'm not working in science anymore. And when I look at, you know, the Tasmanian salmon industry, you know, the industry keeps saying, oh, we need more data, we need more data. And it's like, no, we know that skate is going to go extinct because we know what the problem is. We just need to actually do it. And I think the doing of it is the biggest issue. So how do we, I mean, there's been some wins recently on the, you know, the law of the sea, the high seas treaty. Well, we've got some signatories on it anyway. And we've got these methods, and we've got lots of kids who are taking governments to court and trying to do this through the legal frameworks. Is this methodology of legal frameworks and all of these young people doing incredibly brave things and taking governments to court, God knows what, is this going to be quick enough so that when we actually work out, we've only got 20 years, really, for the reefs, that it's going to be able to be done in time? That's what I'd like to know.
Yeah, what a question. There's so much in that, so much that's depressing as well. I've never worked directly with Ove, but I've worked with someone who's written a lot with, I've written with Alicia Harold Poliob on ocean acidification. I don't know whether we're going to be able to respond quickly enough. I mean, there are a number of positive developments. I think the agreement on biodiversity beyond national jurisdiction is a reasonably positive development. So it was opened for signature a few days ago in New York. I think there's already 81 states that have signed the agreement. They'll then need to ratify it, and it's only when 60 parties ratify the agreement that it will come into force. I've been following the negotiations pretty closely, and I had a PhD student who did a whole PhD on the negotiations. There's lots that's good in the agreement. It does reference climate change and ocean acidification. It does set up a system for marine protected areas on the high seas for the first time. We haven't really had high seas marine protected areas, so that's useful. But it's still weak in other respects, and I think it's weak in that it doesn't include the kind of prognostication that we need. You know, we do need the Oves of this world to come out and say, you know, this is what's likely to happen. And it comes back to the observation I made before. Again, the planetary boundary stuff is helpful because that says, you know, where we need to aim to be under. With the planetary boundaries, I think there's 9 of them. We're already over them on climate change. We're not yet over it, according to the planetary boundaries people, on ocean acidification. We're still in the green for ocean acidification. So I think we need a lot more of that. And here's a concrete example of where it can happen. The Paris Agreement on climate change includes temperature targets that everyone will know. 1.5/2 degrees. We've got to try for 1.5. It's really convoluted language, but basically we want to keep global average temperature increases below 1.5 degrees Celsius above pre-industrial temperatures. So there's a temperature target there, but there's no marine focused target at all. There's no target in relation to ocean acidification. We've got no target in terms of, say, ocean heat content. But some of that can actually be introduced into the process, and that's because the Paris Agreement has this iterative pledge and review system. So countries have to put in what are called nationally determined contributions every 5 years or so. And there's also something called a global stocktake, the first of which is happening or has happened this year, 2023. And there's nothing stopping countries saying, in order to protect coral reefs, we need to do X, and then link emissions reduction obligations to these environmental metrics. And they ought to be precautionary, which is, I think, the essence of your comment that we know enough to know that what we're doing is not helpful. And we, while more knowledge is always helpful, we know enough now to really get cracking. So hopefully that answers at least part of your observation question.
We have another question in the back, and then another one.
Thanks, Anna. I guess my question relates somewhat to what you were just talking about, Tim. Insofar as you were mentioning that the World Heritage Convention is a success story, resulted in the establishment of the Brumper. I guess in the last 10 years, I don't view it as such a success story, in the sense that, particularly relating to the question of whether or not the Great Barrier Reef goes on the list of World Heritage in danger. It's something that's sort of cycled in and out of media attention, and the reef has continued to deteriorate and it's continued to stay off that list. And you were mentioning this idea of metrics and boundary frameworks of safe operating spaces. We have those metrics for the Great Barrier Reef. They tend to focus on local water quality issues, and they've tracked the deterioration of the reef. So at a global scale, yes, those metrics should be temperatures. And I suppose my question is, and I'm asking this as a scientist and you're a legal expert, my understanding is that global temperatures rely on, I don't know, countries, say in the Middle East, whether or not they're mining for oil. So what do the legal frameworks look like to connect somebody who's underwater on the reef going, well, this coral looks like it's about to bleach. In fact, we're saying that at the moment about this summer on the reef. And how do we connect those actions to global actions? What do those legal frameworks look like?
Yeah, so they're not directly connected, which is regrettable. So the way the Paris Agreement works is it doesn't set any quantified emissions reduction targets for any country. It simply says countries must do their utmost to reduce their emissions and must put in these nationally determined contributions periodically. So it's different from the Kyoto Protocol. So the Kyoto Protocol said countries have to cut emissions by a certain percentage. It's just that those percentages were so tiny that it made virtually no difference really to emissions at all. And yeah, we're not joining the dots between big emitters and the impacts of their emissions on coral reefs or other ecosystems. Now, the observation here about what's happening in courts, for instance, is interesting because some of the dots are being joined by litigants. So litigants are able to, plaintiffs are able to go to a court and say, if this coal mine is approved, or if the government, adopts this new approach of supporting emissions intensive industry or whatever it may be, we can actually say that that will have a discernible impact. It may be relatively small, but in the scheme of things, but it's cumulative in impact, and therefore shouldn't proceed. And I think we're getting to the stage now where the bath is full in terms of CO2 emissions. So every additional drop is problematic. And that's really strengthening the hands, I think, of claimants globally. And Australia is the standout jurisdiction for climate cases. Australia and the US, I think this is where most climate cases are being run. And some are being successful, plenty are not. And I think we're just going to see more and more of that. But yeah, we definitely have to join the dots. And I think we also need some more hard diplomacy. We actually need countries calling out other countries. Another development that's interesting, there's a fossil fuel, there's a treaty to phase out fossil fuels. It's like a fossil fuel non-proliferation treaty, a bit like nuclear non-proliferation. A couple of new countries joined yesterday or the day before, including Timor-Leste, which I thought was very interesting. Given you know, how much they, you know, how impoverished the country is and how much they want to rely on, you know, gas coming out of Greater Sunrise and elsewhere. But yeah, it's a big challenge connecting those dots. We still haven't connected them, but let's hope we do. Yeah, go for it.
Can I just make a point that while, you know, our government makes all these claims that they're trying to protect the reef, the bottom line is that everything is based on how many more jobs have we got? How is our economy growing? Do we need to grow our economy? Could we not just, you know, I mean, you know, I'm not a politician, but, you know, we do need jobs, but can we not have jobs that are actually in conservation, not in, you know, exploitation? I have no idea how to solve this, but we also still have a significant proportion of our population that still does not believe in climate change. And, you know, and what are we going to, you know, we're going to have a very dry summer, they're predicting, and lack of rain. So we're going to have another drought. How many more of these events do we have to have before people realize what is going on?
I was kind of just wanting to follow on a little bit with what you were saying before, Tim, and in context of like jurisdiction at different scales, and how the priorities change. And you kind of covered it just before, I think, anyway, but I kind of wanted to phrase my question in a way that's kind of like, do different jurisdictions at the, like, for a problem that exists at a global scale, when the main power of jurisdiction, the highest level of that is at the nation, I think. And some nations are landlocked or impoverished and have clear different priorities. Should they be expected to reduce burning coal and everything?
Yeah, that's a good question. Landlocked countries, how many landlocked countries are there? It's a good trivia question. Does anyone happen to know off the top of their heads? I think it's about 20. Oh, hold on, no, it's more than that. It's about 40 something. I think someone's Googled it. Someone Google it and find out. It's in the introduction. Anna mentioned that I've just published the 3rd edition of the International Law of the Sea with Don Rothwell. And we've got a chapter on landlocked and geographically disadvantaged states, most of which are parties to the Law of the Sea Convention, but not all of them. 44, there you go. I wasn't far off. Or maybe I'll spot on. Yeah, look, most of the big emitters are coastal states with big, you know, marine interests, and all states, including landlocked states, share the atmosphere. So they've got an interest in combating climate change. We're all in it together. And we have to find a way of phasing out emissions, whether that's limiting emissions or limiting the production of things which make those emissions, such as fossil fuels. We do have an example of success in the ozone context. the Montreal Protocol on ozone depleting substances in 1987, the world community came together and agreed successfully to reduce and phase out ozone depleting substances. And we've done that. Now, I know there's been a few bumps in the road along the way. The ozone hole, I think this year is a bit bigger than it has been in previous years, which suggests that maybe some jurisdictions are being cheeky in their reporting of their ozone depleting substances. But overall, it's been a success story, and we can thank, it's primarily British scientists actually originally who detected the ozone hole back in the 80s in their Antarctic research. And that led really quickly to a response, including from a conservative administration in the US, where the government was presented with clear health evidence of how many hundreds of thousands of cases of melanoma there would be if the ozone layer thinned and the hole grew. And that was an economic cost that no government, including the US, wanted to bear. The economic costs of climate change are exponentially bigger than that, yet we haven't yet acted. And yeah, it's for a whole host of reasons, including because fossil fuels are embedded in so many human activities. Fossil fuel companies are very powerful actors, political actors, but there's no reason in principle why we couldn't have a phase out type model, and maybe we will get there. I am still hopeful, and I still do think people do respond to shocks. I mean, Pat referenced, you know, how many more shocks do we have to have? I think people have a visceral reaction. I've been involved in the climate activism movement for a long time as well, and people used to say, don't scare people, you know, don't use the scary message. It's all got to be about the positives. But actually people do respond when they're told, actually, you know, maybe temperatures are going to be you know, you're not going to be able to live in certain areas. That's pretty scary. I think we ought to do something about that. I think we're rational animals, and we ought to respond. Well, we're not always rational. We're sometimes rational animals, particularly when it comes to primal needs. So anyway, I think we can do it, but it's going to take a lot more kind of shock to the system before we get action.
Just one comment on that. I think, yes, we will react when people start seeing, you know, wildfires and other major issues and directly affected by it. One of the big problems we have is that is different to when we had the greenhouse, you know, the ozone layer thinning, is, you know, social media. And we all know the power of that in the latest debate with The Voice and all the misinformation that spreads like wildfire. Everyone's a, you know, expert when they get behind a keyboard and in privacy. And, you know, people say they care about something, but they're not necessarily wanting to do the research. So they form an opinion straight away and hold to that. So I think that's one of the biggest challenges that governments face is, you know, and some of those lobbies you mentioned are behind some of that misinformation. And it's a real worry because it just takes so long to make a decision about something. I think eventually we'll get to a point where, you know, the numbers will be that bad. There'll be, you know, places like Bangladesh that are, you know, basically sitting at sea level, are going to be majorly affected by any rises in sea level. And when you combine that with the intensifying storm, then, you know, you've really got issues. So it's not all good news, but I think, yeah, it's harder to get things done now that everybody's an expert.
Thank you. Yeah, I see microphone with no one.
Yeah, I have a question. It actually follows on from what you're just saying, sort of looking at the negatives also. And this question is for the whole panel, but what do you see as sort of the implications of a complete collapse of the Great Barrier Reef here? So what are we being warned about with this emergency, in your view?
Okay, the reefs I saw in the 70s are not there now. If you at a recent function, I saw some photos of the recovery of corals at Lizard Island, but it was all the fast-growing acropolis. It wasn't the reef that I knew. So we're already seeing it. And while it's happened in geological time periods, it's the speed at which it's happening. And, you know, it's changing. I don't think we're going to end up with an algal-dominated reef.
Yeah, I think, and you know, that changing is what we're also seeing at the markets with geographic distributions of different species. So, you know, the more tropical species are heading south. And, you know, it's not all bad news for fisheries, because some of those species that are increasing in abundance are actually worth money, and, you know, there's new fisheries being created. The scary bit is when you get to the bottom end, where are those species going? So things that just can't go anywhere cooler, you know, they're starting to drop off in numbers. And so, you know, looking at it from that perspective, you know, what I guess the reefs, you know, always been, you know, this wonderful home to such a variety of species, and that boundary between reef and mangrove is so important for fisheries production because it's a natural nursery. And as we see destruction of both, that's only bad news for fisheries. And, you know, one of the other issues as well is people are, through misinformation and other things, they're just questioning science in general. And people like, you know, Dr. Tim Flannery, when, you know, climate change was first being talked about, unfortunately, when us scientists sometimes talk about things, we're speaking in geological sort of timescales and saying, oh, you know, it's going to be 10 degrees warmer next year. And then the skeptics take that literally, and then point to that as evidence when it doesn't change in that sort of rapid amount of time. They then use that against you. And, you know, we saw it with the COVID epidemic. You know, there's all sorts of misinformation happening now about, you know, it's, you know, big pharma or someone else that's plugging all this, you know, data out there that's saying basically scientists are wrong. And so, you know, how do you counteract that? It's such a challenge because, you know, science is sort of less of a priority, it seems. And, you know, thankfully you guys are doing science.
Oh, I was just going to follow on from, well, probably not answering your question, but just you know, you said that it would be useful to have like metrics and, you know, what are we going to lose with 1 degree or 2 degrees? And I feel like we already have those metrics, but I also feel like, yeah, it's often used against us because there's going to, reefs are so variable and it's so hard to just pick a specific level that we're going to lose everything. So it's hard to then have the skeptics use that information and say, oh, well, you said you know, in 20 years we're going to lose it, and look, there's some here. So it's like, how do you balance that? Like how clear metrics, like how can we provide clear metrics when they'll be used in the opposite way? So, sorry, that wasn't answering your question, but something I want to know.
I actually, and I think it's down to technology. Like my sister-in-law recently sort of was on a project. It was part of, it's sort of like Google Street View, but underwater. I think it's called a Catalan project. And that was essentially flying an underwater drone or moving a camera and getting 3D coverage of the transects. Now, if we could do that over a much greater scale, like the whole barrier reef, you can then start to get real data about the change. And to your point, you know, like Pauline Hanson jumps in the water off, you know, southern Queensland and in amongst the healthy part of the reef and says, well, what's all the fuss about, you know? It's like, you know, you can't just sort of cherry pick areas. You need to get data of the whole system. And I think technology can help that. It's just whether there's going to be funding to do it.
And just on that, I mean, even though some of this work's already been done, I mean, Terry Hughes's aerial surveys of the reef have been amazing. Yet he still gets a whack in the Australian every other day by skeptics reckoning that he's making it up or the reef's fine, it's recovering. So yeah, they're just disbelieving of evidence in plain sight. The ecological collapse point is a really interesting one. I mean, I don't know what happens if the Great Barrier Reef collapses ecologically. I simply don't know what that would mean for the ecosystem, the marine ecosystem. Obviously, terrible for the ecosystem in terms of human impacts. There would, be a huge loss of income from the tourism sector and the fisheries sector, but maybe that'll be counterbalanced by more productive fisheries, in different latitudes. I don't know. But yeah, it's hard to predict, but also I think we're also still thinking in a kind of linear way that we're going to get, gradual change and maybe the occasional shock. What worries me more is that we're going to get really rapid change and things, out of control very quickly, which will affect this little one more than, it's necessarily going to affect the older ones in the room.
Also, all of us, when we go on a reef, we sort of regard that as a sort of baseline. But, reefs have been changing. I mean, the first time I dived off Tahiti, I thought, there's something the matter here. There's no big fish because they've all been fished. There's only little things. So even when you're looking at a reef back in the 70s, there'd already been decades of fishing. So, what is the baseline? What is the good reef?
We'll have one or two more questions, and then we'll extend the discussion to the light refreshments.
Just like to get your opinion on a couple of things that have developed recently. Just a bit of hope to try and finish on. I do my best. You've got California now suing the big oil majors a la big tobacco sort of style. And California is one of the biggest economies on the planet. You've also got a little tiny place called Wales that has this wonderful Well-being of Future Generations Act and the Future Generations Commissioner. If you haven't listened to that on the press club address, it was fantastic. That seems like a methodology for fixing this sort of stuff, because that builds in the precautionary principle. I mean, I know that Treasury is going to try and do a well-being budget, but I suspect it's nothing to do with this, which is looking at future generations, and it's an act of Parliament that forces the government to view it through how it will impact on future generations. Is that, I mean, do you know about that framework, and do you think that could be implemented?
A really fascinating development in Wales and elsewhere. A colleague of mine at the University of Tasmania has been doing a fair bit. Peter Lawrence is his name. He's written a lot on commissioners for the future, or for future generations, as a voice or an advocate for future generations. But we haven't really scaled that up, certainly at a global level. There's one or two kind of national examples. Bhutan's another place where everything is kind of focused around well-being and not just economic productivity. I think the new Australian government's budget will look at that issue. And I think the Treasurer has also asked the Future Fund to look at future generations in terms of environmental impacts as well. So yeah, there's some promising developments. And Gavin Newsom in California suing the oil and gas majors is definitely a welcome development. Litigation is really messy, really expensive, but it can produce some pretty amazing outcomes, whether that's the Dominion voting machine company suing Fox News in relation to misinformation about the US presidential election. That was $1 billion settlement or more. you know, that's actually a positive news story for the climate as well, because it's knocked, you know, pretty hard, one of the engines of misinformation. So yeah, litigation's a great place to go. So yeah, and so this is a good call out to the scientists in the room. If you get a call from a litigator and you can help them, please do so. You know, as an expert witness, it's a good way of making a little bit of money potentially if you win and then get costs. But do it for the love of it and to save the world, not just for the cash.
Can I just say something? I had my hand raised and I gave myself the microphone. So, but I really want to continue on what Tim just said. How many of the people in the audience and in the panel have science degrees or are doing science degrees? Yeah, a few. How many have you ever considered joining a political party? Becoming, yeah? Not that many. So we need more scientists in politics. That's my conclusion every time at these panels. Anyway, Monique, go ahead.
My question is for Pat. You've worked at the museum for a long time and you said that you had your Polykeet workshop. Those are one-off events. So my question sort of has two parts. Do you use industries such as fisheries to collect species over time so you can see how they've changed and how, such as sea urchins, how their test might change due to ocean acidification and things like that? And have you seen a change so far?
Certainly there has been some development in mollusks of looking at the museum collections of shells to see how they become thinner over time. We did try and look at one stage, look at whether we could plot distribution changes. And we can see it for mollusks, but we haven't been able to show it for other groups, mainly because the collections are not, people go out and collect for their own research, but perhaps they don't do a comprehensive survey all the time. So the collections have limitations. I know I've been talking about trying to set up standard transects, and people go and collect there, say, every 2 or 3 years, so that we can see how the species are moving south, or some species are. And I know Maria Byrne's been doing that with some of her echinoderms. But it's also a question of funding. Museum research museums are all state funded, and state governments at the moment are more concerned about health and educational policing. So our budget doesn't really go up. I mean, Lizard Island Research Station is largely funded, apart from the 4 staff that are employed, it's basically funded by donations from the general public. I mean, it's been very, very successful in raising funds, but yes, I think, you know, we can, but I mean, look, I do despair at times. I mean, you know, perhaps I'm glad I'm not going to be here in 30 years' time, because the reef is not going to be the same. And, you know, I just seeing the loss of mangroves and, you know, the mangroves dying up in Northern Territory with the heat, and that impact that's going to have on the coastal communities. Yes. And while you know, I do despair at times, but you're the new generation. You need to get active out there and encourage our politicians to say, we don't need more jobs, or we do need jobs, but in industries that do not pollute.
Oh, I said not many more questions, but I have one and I haven't done it. And I have the microphone. My question is to Eric, and that will be the last one, and then we keep talking later. Actually, because Pat just mentioned, and we've been talking a lot about the scales, global scale, local scale, what is relevant and how we deal. And I think we've kind of didn't talk that much about what about the local community. And I'm wondering, how is that local community where you grew up how they are doing now. How afraid are they for the way their life goes in the future?
Yeah, I think it's not good news. You know, people. My mum's village is basically on a beach, and it's a pristine white beach with, you know, palm trees. Looking back through sort of childhood photos and photos that my dad took when, you know, he first went there, you can actually see the change. You know, in those communities and as in lots of other Indigenous areas, they generally use sort of marker trees to delineate, you know, boundaries, and, you know, of where land claims are, and it's highly customary. And, you know, all of those things have changed. You know, there's photos where, you know, an entire section of palm trees are just gone. And so people are just moving further and further back. So they sort of, luckily, PNG's, you know, it's a geologically active country, so there's quite steep mountains. So the people can sort of retreat from that rising sea level. I despair for those places where they can't move, and places like Tuvalu and others, where it's not just the, you know, the sea encroaching, but it's getting into the groundwater, so they can't grow crops anymore, and their freshwater sources are gone. So, you know, even in Sydney, you go to some parks now, like over in the North Shore in Neutral Bay, there's a park where all the grass just died, and they've replaced it, but I'm sure it's going to die again because there's an old drain that runs alongside it, and at high tide, the water's actually getting higher and higher. Jeremy and I actually play there a lot, and we've sort of noticed changes. So, you know, in the West, we're lucky because we can always find something else to eat, or we can, you know, move somewhere else because we have the resources to do so. It's those, you know, poorer third world countries that are really going to feel the brunt of this. And, you know, and unfortunately, we're very good at drawing up borders. So, you know, as you saw with boat people and other things, we can very easily, you know, close the door. But the people in those other countries are the ones that are really going to feel it.
Thank you. Thank you, all of you. I'm so thrilled with all the awareness that this panel managed to put up. So yeah, thanks to all the panelists. Put your hands together and let's start for them. I also want to, in my name and Shauna's, thank the Marine Studies Institute to invite us for co-chairing and organizing this event. And I want to thank Professor Ana Villaconcejo and Professor Eleanor Bruce and Dr. Tommy Fellows and Annika van den Brink that is just outside for all the support today in this event and in all the events, because this is annual. So next year there is another seminar, and please join us. And yeah, we are all free to have some light refreshments now. Thank you all for being here today.